Rocket science is the science of designing, building, and launching rockets. It is a complex and challenging field that requires a deep understanding of physics, engineering, and mathematics. Rocket scientists use their knowledge to develop new and innovative rocket technologies that can be used to explore space, launch satellites, and transport people and cargo to and from orbit. The basic principles of rocket science can be explained by Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. When a rocket engine ignites, it expels hot gases out the back of the rocket. This creates a thrust force that propels the rocket forward. The rocket's payload, which is the object it is carrying into space, is attached to the rocket's body. The payload is also propelled forward by the thrust force. In order to reach orbit, a rocket must overcome the pull of Earth's gravity. This requires a significant amount of thrust force. Rocket scientists use a variety of techniques to increase the thrust force of their rockets, such as using more powerful engines and lighter materials. Rocket science is a challenging but rewarding field. Rocket scientists play a vital role in space exploration and the development of new technologies. Here are some of the key areas of science and engineering that are involved in rocket science. Physics. Rocket scientists use their knowledge of physics to understand how rockets work and to design and build rockets that are efficient and safe. Engineering. Rocket scientists use their engineering skills to design and build the different components of a rocket, such as its engine, payload, and guidance system. Mathematics. Rocket scientists use mathematics to calculate the forces and trajectories of rockets. This is essential for ensuring that rockets reach their intended destination safely. Rocket science is a complex and challenging field, but it is also a very rewarding one. Rocket scientists play a vital role in space exploration and the development of new technologies. The basic principle of a rocket engine is Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. When a rocket engine ignites, it expels hot gases out the back of the rocket. This creates a thrust force that propels the rocket forward. The rocket engine works by burning a fuel and oxidizer in a combustion chamber. The combustion produces hot exhaust gases, which are then expanded through a nozzle. The nozzle accelerates the exhaust gases to a high velocity, which creates the thrust force. Rocket engines can be classified into two main types, liquid-fueled and solid-fueled. Liquid-fueled rocket engines are more complex than solid-fueled rocket engines, but they are also more efficient and can be throttled. Solid-fueled rocket engines are simpler and less expensive, but they are also less efficient and cannot be throttled. Here is a simplified diagram of a rocket engine. The main components of a rocket engine are: combustion chamber. This is where the fuel and oxidizer are burned. Nozzle. This is where the exhaust gases are accelerated to a high velocity. Injector. This is the device that injects the fuel and oxidizer into the combustion chamber. Pump. This is the device that pumps the fuel and oxidizer into the injector. Rocket engines are used in a variety of applications, including space exploration, launching satellites, and transporting people and cargo to and from orbit. They are also used in some military applications, such as missiles and anti-aircraft weapons. Rocket engines are very powerful and efficient, but they are also very complex and expensive to build and operate. However, the benefits of rocket engines, such as their ability to operate in a vacuum and their high thrust-to-weight ratio, make them indispensable for space exploration and other applications.